Hello friends, welcome back to Giga Tech. So one of the key aspects of the PLC programming is to connect the hardware to the IO card and read those variables or the data into the PLC program and utilize them into it. So how exactly it is getting done, how we map those variables into the different IO cards, and what are the different ways in which we can read them into the CoDeSys. So let me talk here about how exactly we will be able to map all those variables into the multiple ways into the CodeSys. So first thing is to scan the PLC where we have already connected the IO cards. So there are two ways, either scan the devices or add them directly into your program and load it. So here I'm going to give you example for the scan for the devices. So once we right click and go and click on the scan for the devices, as we are doing it for the first time, so it will ask for the username and password. So we will provide that, and then it will scan all the IO card which are connected to the PLC. So once these IO cards are scanned, we can see they are scanned in a order in which they are connected into the PLC. So we can now copy them into the project. So for that we need to click on the copy all devices to the project, and once we click this, all devices will get added into the bus, the field bus which we have. So now as we copied them, so it has came into the device into the field bus, and now we can be able to see how exactly these cards are, how many IOs are there, what kind of IOs it is. So all those things we will be able to analyze. But are these cards which we have scanned are exactly the same card which are connected on the hardware? Let's see that also. So first let's go one by one into the each card, and we can see that these cards are having different configurations. One for something is for digital input, digital output, analog input, and uh, serial cards are there. So these are the totally different configuration which we have. Okay, so now let me bring to you how exactly the hardware configuration are done and how exactly the IOs are connected on the PLC, which all modules are there. So we will match whether they are matching with our internal configuration or not. So if you can see that we have card 430, we have card 530, uh, but those are not matching here in the card configuration. So what we can do, we can go to the cards and right click on there and update the device. So in the update device we can find the respective modules. Okay, so we can search in the search bar for the card which we want, and then once we get the card into the search bar, then we can update that particular module with that, so that it should matches with the real hardware configuration. So in a similar manner we will do for all. So that is why I started with the scan. So how exactly we can scan, and then we can also add or update the devices directly into the IO configuration. Sometimes it get all the IO which are configured in the IO card as a generic module. Okay, so but we need to update as per the configuration. So we will do it for all the different IO card, and then we will go for the download. So let me do it one by one. So it takes some time to get updated. Okay, so I'm skipping that part and getting it done faster. Okay, so once we have updated this all cards, so it will automatically get reconfiguration also. So we don't have to even rethink that I have to go and update somewhere, but it will get automatically reconfigured for all the places where it has been used. So now I have downloaded I will download the program. So if you see right now all the modules are in triangle with red color, so these are not detected because my PLC is in stop mode. Once I will put it into the run, then it will become green and all the modules are detected. So on the other side I have two proximity sensor, NP and PNP for the digital, and I have analog input module which is connected to analog input card for the 4 to 20 milliampere source. Okay, so here if you have seen that even I have downloaded the program, but those IOs were in the grayed out mode. Why it is happening because those IOs are not at all utilized anywhere in the program. So this is the first way in which I'm going to show you how exactly we can map and how exactly we can use those IOs into the program. So I'm defining here two boolean variable, and so di1 and di2 as a boolean variable, which I will be utilizing it into the digital input card. So once we have defined it here, so I have defined just the variable. So I will go back to the IO card, and then I will browse here for the PLC program and the application code. Okay, so I will open it, I will go to the PLC program, and I will click on the di1, so it get mapped. So now if you see here, the address will get extracted out. Okay, so now it is not using address, it is the direct variable mapping on the IO card itself. So similarly, we will do for the second IO module also, second channel basically, and di2 I'm mapping on the second digital input channel. So now these two digital inputs are mapped. Now if we download, then it is defined in the program as a variable, and I have downloaded it. So it should not be in the grayed out, but let's see how exactly it behave, because it is not even right now utilized. So defining a variable doesn't mean it is utilized in the program. Okay, so that is what we need to check. So if you see here, once it get downloaded, it remains in the grayed out state itself still. Okay, that is why, because it is not utilized. So we are not using it in anywhere the program, so here we will not see any change. So because these are only defined, so let now utilize them into the program. So I'm just using those variables di1 and di2 into the programming part. Okay, and once we have utilized them into the program, then after that, once we download it, okay, then after download we will see how exactly it is behaving. Is it will get it will not be grayed out, and it will be showing with a value either true or false based on the condition of that particular IO or that particular channel. Okay, so now we have utilized this into the program, and now if I go back to the DI card, and there we can see, let me double click. Yeah, here if we see that this particular two channels are in the false state, because there's status coming on those channels as a false. Okay, so this is one of the aspect in which we can be able to map the variable and utilize them into the program. So let me show you another way. So there are multiple ways in which we can be able to utilize this mapping part in the CoDeSys. Okay, so another way of doing the mapping part, which I'm going to show here, is the utilizing the bit by bit mapping. Okay, so for each channel, if we have seen that we have the address defined, so I'm going to utilize those addresses using the pointer as at. So at, and then we will give the address of that particular channel. So like percentage ix 0.0 or 0.1, so like that we will provide here, so as you are seeing, and then we will map this variable to the memory address or the IO address of the channel. So this is the another way to you do the mapping. So in this way, what we are doing is we are utilizing those addresses into the program, and then using that, when we download, these IOs get mapped with the variables, and as they are getting utilized into the program, so they will get we will be able to change the value and see the behavior on those particular channels. Okay, so right now if you see here, these channels are marked as false. Okay, and let me download and change the address, so it will show that how exactly I have connected the proximity sensors on different channels, and we can utilize that to see the behavior of the hardware, exactly how it is behaving. Okay, so I'm just changing the channel number and downloading it again. So we can see that the value for the second di2 is true. Okay, now if I make it closer to some metal contact, then you can see that the values are changing. So this is how we can utilize the direct channel addresses with the variables to use them into the CoDeSys for the mapping of the IO. So this is the second type of mapping which we can utilize uh, into the program. So now let's see the third type where we are not utilize the bit by bit or channel by channel address, but we will utilize the whole address. So right now what we were doing is we were trying to map to each channel, and we were utilizing only those particular channels which I have connected the IO. So if we want to utilize the full channels, then we will be having a different kind of mapping, and we can use the same bit by bit, but if we want to utilize directly at one address, then we what we can do is, instead of bit by bit mapping, uh, if we can go to the card and see that I have a main address as IB, percentage IB, because its whole thing is byte, and rest are defined in boolean. So we can define that as a percentage IB0 directly. Okay, and when we define that on DI1, in that case I'm just commenting on another one, and when we download the program into the PLC, then once the program get downloaded, we can see that all the IOs, okay, not only the particular channel but all the channels will get activated, because we are using right now IB0, the main address. Okay, so main address is the full channel. So in this way, if we have to utilize all, so instead of going by channel, we can use directly the main uh, byte address, and if we see that, we will be able to even see the change in the behavior of the all the different channels. So as I have connected two proximity, one is NPN and one is PNP. So based on that, we can see the different behavior for those particular channels. So this is the another way of the mapping of the IOs in the CoDeSys by utilizing full address. So the main address, which is defined as a byte, and rest not the boolean address or the byte or the channel address. Okay, so this we were seeing mostly for the digital input or boolean bits. Let me also show you how exactly we are reading that for the analog input. So I'm defining here uh, one variable for the analog input, and defining the at particular address directly. I'm mapping that to address of the particular card, AI card. Okay, and so this is the AI card. So if you see the first address which I have utilized, and I need to use that particular variable as in the program, so that it is getting utilized in the program, and then we can be able to see the changes at the particular IO, because until unless it is not utilized, it will not be getting shown any of the changes on the particular IO. Okay, so once I download this particular program, we can see that the values are automatically changing, because I have connected a 4 to 20 million pesos, and right now it is coming in the counts, because it is the card which is giving me the properties, everything comes in the counts, and then we have to scale it according to our requirement. Okay, so this is how exactly we are reading the different types of IOs into the PLC program. So here if you can see that even on the channel, the value for the particular channel is changing, because I have used only the first channel, rest I have not used. Okay, so uh, that is the difference when we are using for the particular channel or the full address. So that is another way of doing the mapping into the PLC program. The another thing is different ways is to use as a function block. So let me create a function block here into the program, and I will define that as a IO mapping function block. So what we need to do in the function block? So we need to define this particular function block with a pragma called which where we define it into the curly braces as attribute, and we give the pragma name as IO function block. Okay, so IO function block pragma, when we use, then it tells that this particular function block is will be utilized for the IO mapping. So let's me define it here, and then let me also define some of the variables. Okay, so like we have digital input cards, so I'm defining that into one input as di uh, 1 and di2 with boolean type data type. And let me once download this particular, or when I go into the particular FD function call, but I am not able to see, because only what we have done is we have defined the first pragma, correct? So we have defined that this particular function block is a IO function block. Now what we need to do is we need to define another pragma before the IO variables. Okay, so where we will see say that this particular variable will be used for mapping. So what I'm defining is IO function block mapping. Okay, now let me build it. And once we have built, and when we go back to the particular module and click on the function block, okay, when we click on the function block, then we will see that the particular arrow mapping is getting shown. Okay, so when we click on that particular function block and click OK, then the channel will get automatically mapped. And if you see in the mapping part, it is showing that it is coming from the function block FB. So it will show as a FB, and it created an instance of that particular function block. So function block is called, mapping is done, and if you see, it has utilized the first bit only. Okay, di one. Now if you see here, when I mapped it on second channel, then it has created another instance. Okay, so if you see here, the instance is getting changed for different channels. So another thing is we can also define it, because we have defined in the var input as two different variable di1 and di2. So when we copy and paste it on another channel and map this with another variable called di2, then as it is not defined as a mapping variable di2, so you will not see in the mapping as a fb. But this will also work, because the instance is created, and from that instance I'm utilizing another variable. Okay, so where exactly this instance are getting created, so if we can go to, so let me create one more instance. Okay, so three instance we have created, and for instance when it is created with the function block, it will show there as a function block, but variable when you use, it will not show as a function block. And here if you see, three instance has been created for the same function block, and these are not getting called in the PLC program, but these are getting called directly on the IO modules. So when we download it and go online with the controller, then we can see that this all IOs will work, and we will observe the changes from the field. Okay, so in this manner we can utilize even the function block and the pragmas called IO function block and IO function block mapping to map it on the IO card on different channels. Okay, so this is another way of doing the mapping. In this one, I will show you just later how exactly they get mapped automatically when we define it in a different ways for digital output or analog input. Okay, so now if you see, these are working exactly how it has to. So because instances are created, and we will observe the changes on the different channels. Okay, so now let me go to uh, offline, and let me go on the digital output card. Okay, so digital output module. Now if here, if I go and click on the function block, I will not be seeing any of the function block. Why? uh, we have defined the function block in the PLC program, and we have also defined the pragmas, but still I am not able to see, because if you see here, we have defined the variables and the mapping only for the input. Okay, so now let's copy those variable and put that into the var output. So we have the pragmas for mapping, and I will just change the name to do1, so it will be the digital output. And let me then build it. Once it get built, then we will go back to the digital output module, and if we call function block, then we can see, and when we click on that and add, we will see that directly the do1 get mapped on the channel 1. Okay, so it takes the variable automatically where we have defined the mapping. So depending on the variable type, var input, var output, it takes those variables into the consideration for that particular module. So based on whether it's a digital input or digital output, which one it has to map where, so everything it will get mapped. So we can download the program and we can see that this particular function block is mapped to do1, and when we do a change on the do1, as I have looped back the do1 to di2 of the module of the digital input, so when I change the variable of the digital output, the digital input too will get also changed. So it will work as exactly it has to. Okay. So let me bring it on the same view. And now if I, yeah, so if we see that the di2 right now is false, because here do is also false. And when I change the do to true, then so when I change the do1, then the di2 will get changed. Okay, so when I change it to true, it will become true, and when I change it to false, it will become false. So in this manner, we can see that how exactly we are utilizing the function block for even the do. Okay, so now let's go back to how we can utilize the same function block even for the analog input. Okay, so right now if we go and click on the channel and click on the function block, we are not able to see any function block here. And so let's go back to the function block IO mapping, and there what we can do is we define one variable, okay, a1 as int, okay, integer type variable we have defined, and copy the mapping pragmas and define it before, put it before the variable. Okay, we will build it, and then once we go back to the analog input channel and click on the function block and add, so if you see, it will automatically add only the AI1. It will not add the DI. So DI is var input but boolean, and AI1 is var input and it is integer. And here the data type is integer. So it checks which particular variable is getting mapped, and for this, and it will automatically map those variable only into the particular module. So in this manner, we can be able to utilize the single function block for all the different kind of modules. So that's all in this particular video.
Thanks for watching. That's all for this video. See you in the next one.